Hey everybody, welcome to 6B, Solving Quadratic Equations, Chapter 6.2. So here we'll be solving, and then we can verify with decimals or substitution. Now, equations. Again, the difference between an equation and an expression is simple. Equation has an equal sign. An expression does not. Okay? So, what is it saying? It's saying, well, I want you to find the x value that will make the statement true. Okay? So remember when back in grade 9 we were solving, or grade 8 or grade 7, we were solving questions like this. What is the x value? Okay? Well, you knew to move the 9 over, 18 minus 9, or subtract 9 from both sides. That means x will give me 9, right? We can't do that here, can we? If I move the 14 over, I'm still stuck. I still have two x's there. This is where all the factoring skills come in handy. Okay? Now, to solve this, we're going to factor. So I need two numbers that will multiply to give me 14, but add to give me 9. Yeah? First off, can I common factor? No. Is it simple factoring? Yes, because the coefficient is a 1. So what are those two numbers? Looks like it's a positive 7 and a positive 2. 7 and 2. Okay. So then my two roots are x plus 7, x plus 2 equals to 0. So now, how does this help us solve it? Well, again, we're trying to find the numbers such that if I plug it in for x, this whole statement will equal to 0. Well, since I factored it, this standard form and the factored form represent the exact same equation, doesn't it? Now, since it does, that means I want this whole thing to equal to 0. Well, if I want this whole thing to equal to 0, then either this first factor equals to 0, x plus 7 equals to 0, or x plus 2 equals to 0. Okay? So if I solve for this, I can subtract 7 from both sides or move the 7 over. That means my x value would equal to negative 7. Same thing over here. Move the 2 over or subtract 2 from both sides. I'll get x equals to negative 2. Now let's see if this statement's true. So if I were to plug this in back to my original equation, so x squared plus 9x plus 14, does it equal to 0? I don't know. Let's pick one. So if I picked negative 2, negative 2 squared would be 4. Negative 2 times 9 would be negative 18 plus 14. Does this equal to 0? 4 minus 18. Oh, sorry, this should be 14. Okay, there we go. That makes more sense. 4 minus 18 is negative 14. Negative 14 plus 14 is 0. There we go. And again, I could do the same thing. If I plug in negative 7 up here, negative 7 times squared is 49. Negative 7 times 9, negative 63, plus 14. Type that in your calculator, and you should indeed get 0, which means this is correct as well. Okay? Simple as that. Let's take a look at the second one. What should we always check for first? Common factoring. That's right. So if I factor out an x from both of them, what am I left with? Just 2x plus 5 equals to 0. Well, in this case, one of my answers is clearly going to be x equals to 0. The other answer is going to be 2x plus 5 equals to 0. Now, why does this make sense for this one, for this first solution? Well, if this was 0, then does it matter what this is? No, because 0 times anything is 0. And if I want to check this very quickly, I could. 0 squared is 0. 0 times 2 is 0. 5 times 0 is 0. 0 plus 0 is 0. Okay? Let's check this other solution. So I'll get 2x equals 2. Move the 5 over to get negative 5. Divide both sides by 2. X equals 2. Negative 5 over 2. Now once again, I can take that value, that's negative 2.5, into here. Negative 2.5 times 2 is negative 5. Negative 5 plus 5 is 0. And there we go. Okay? Last example. So, I look at this and think, what? It doesn't equal to 0. Well then, you're right. Let's make it equal to 0. So I'm going to negative x, move the 15 over, which makes it negative 15 equals to 0. Now I just got to factor this. Okay? Now I'm just going to erase this so it doesn't confuse us. Can I common factor 6, negative 1, negative 15? No, not really. Can I complex factor? Maybe. Let's find out. Well, I need two numbers that will multiply to give me, so let me just use blue, whatever 6 times 15 is. So 6 times 15 is 90. Okay, so I need two numbers that will multiply to give me negative 90, because negative 15 times 6 is negative 90, but at the same time must also add to give me negative 1. And those two numbers are going to be negative 9 and 10. Is that right? No, that's not, because negative 9 plus 10 is not negative 1. In fact, it's going to be negative 10 and positive 9. So positive 9 and negative 10, which means that gets split into negative 10x plus 9x. Okay, and then I'm going to copy the rest of it down. 6x squared minus 15 equals to 0. And then I can factor by grouping to find out what the two roots are. So looking at these two, what can I factor out of that? It looks like 2 is the best I can do, 2x. So I factor out 2x out of there. What am I left with here? 6 divided by 2 is 3, x squared. If I factor out an x, I'm just left with single x. Negative 10 divided by 2 is negative 5. And since I only had the 1x there, I factored it out. That's it. Now let's look at the other two. 9 and 15, looks like all I can do is a 3. Okay, so I'm just left with a 3x, because 9 divided by 3 is 3x. Negative 15 divided by 3 is negative 5. Okay. Equals 0. Okay. Now, I'm going to look at these two terms. One term, two terms. What's common in both? Well, clearly they both have a 3x minus 5. Okay, so my two roots are 3x minus 5, and whatever's left over, 2x plus 3, 2x plus 3 equals to 0. Am I done? Almost. So to solve for x, I just need to set this equal to 0. 3x minus 5 equals to 0. Move the 5 over to get 3x equals 5, positive 5. Then x equals to 5 over 3. Let's take a look at the other solution. So 2x, what was it, plus 3? Yeah, 2 plus 3. Sorry, I couldn't read my own writing. Move the 3 over, I get 2x equals to negative 3. Then x equals to negative 3 over 2. Done. Those are the two solutions. Okay. So when you are solving quadratic equations, we are essentially just factoring. Okay. So I've got two more examples here before you dive into your practice questions. So the path of a stone is thrown into a ravine is modeled by this equation. Okay, so I'm going to write that down, because chances are I'm going to need that. Where x represents the distance in meters traveled horizontally, and y represents the height in meters above the surface of the river at the bottom of the ravine. How far does the stone travel horizontally before it hits the water? So it's asking us, this. So I know that this is the y-intercept, so I'm guessing we're going to start at a height of 84. Okay. Now it's asking, how far does the stone travel horizontally before it hits the water? And I'm assuming there's the water, and there's maybe, I don't know, a cliff of some sort maybe. The path of a stone is thrown into a ravine and is modeled by that, where x represents the distance in meters, so this is the horizontal distance. above the surface of the river at the bottom of the ravine. How far does the stone travel horizontally before it hits the water? So we want to find out what the x-intercepts are. We want to find out what this value is. Because if I find out what this value is, then I will know how far it traveled horizontally before it hit the water. It's not asking vertically, it's asking horizontally. Okay. Now we're going to get two values. We're going to get two x-intercepts. There's one here and there's one back here. But we're making the assumption that we're starting at a height of 84 and that going back, well, we're not going to go back into the cliff here. Okay, so let's factor this. And what does y represent? Y represents the height. So this is the height. Now, in other words, we want a height of 0. Okay. Now, there's a couple things we can do here. I can complex factor with the fact that this is a negative 1. Or, I could just simply divide everything by negative 1. Okay, to get rid of my negative 1. So I get 0 equals x squared. Positive 5 minus negative 1 is negative 5x. 84 divided by negative 1 is negative 84. So I need two numbers that will multiply to give me negative 84, but at the same time must add to give me negative 5. Okay. Now this will take some trial and error. So 84, let's see, 7 times 12. There we go, 7 and 12. So I know 12 and 7 are the two numbers, but one of them must be negative, because I need to add them to give me negative 5, which means negative 12. So 0 equals x minus 12 and x plus 7. Are we done? Almost. We got to find out what the actual values are. So in this case, let me just scroll down a little bit. I will have x minus 12 equals to 0, which means x equals to 12, and x plus 7 equals to 0. Move that over, x equals to negative 7. Well, x equals to negative 7, like I said before, doesn't really help us here, does it? It's back here. X equals to 12, so this value being a 12 makes a lot more sense. So this is the answer we're going to use. How far does the stone travel horizontally before it hits the water? Therefore, the stone travels 12 meters horizontally before it hits the water. Okay. Alright. And one more question here, and then we're done. A rectangle has dimensions this and this. So I got myself a rectangle. Dimensions, doesn't matter which is which. Nope. 3x plus 1, 2x minus 5. Its area is that. So what's the area of a rectangle? Well, I know it's length times width. Okay? Which means my area, 1150, equals the length, 3x, plus 1, times the width, 2x, minus 5. Now it's just a matter of expanding it and solving it. So I have 1150 equals, if I multiply these two, 6x squared, multiply these two, negative 15, these two, negative 15x, plus 2x, minus 5. Okay? And I'm going to collect a bunch of like terms. I'm going to move the 1150 over to give me 0 equals 6x squared. Negative 15x plus 2x is negative 13x. Negative 5. Negative 5 minus 1150 will give me negative 1155. Okay? Those are some really big numbers. So let's see if we could simplify them a little bit. And that will be negative 13. So 1150, 6x squared, and just double checking some numbers here. Minus 15x plus 2x minus 5, good. Negative 15 plus 2x, 6x squared minus that. Okay, and then you got 6 times. Alright, so in this case, we are supposed to factor this, but we can't, can we? I mean, we could try to common factor, but clearly that's a 13, so that's not going to happen. We can't use simple factoring because that's a 6. Now we could try common factoring, or not common, sorry, complex factoring, but we would need two numbers that will multiply to give me what 1155 times 6 is, which is 6,930, but at the same time let's add to give me 13. And that's going to be a bit of a stretch, okay? Now, as of right now, how do we solve this? Well, we can't, okay? Because we are supposed to use something called the quadratic formula, which is going to be, I believe, the next lesson or the lesson after that. So for now, I'm going to leave this question, okay? And we are going to come back to it, okay? So you should be able to answer the rest of those practice questions. If you have any other questions, please post on math questions. Okay, thank you. Bye.